Good afternoon, Pads. I am here to report the chapter 11, Predicate Logic. So what is predicate logic? A predicate is a symbol which represents a property or a relation. For instance, the first formula P, the symbol P is a predicate which applies to the individual constant A. Similarly, the formula display style R, the predicate R is a predicate which applies to the individual constant A and B. So, ang usa day kuno ka predicate kay nay adunay mga variable. Mahimo nga usa ka proposition pinaagi sa pagtugot sa usa ka kandidad sa variable o pinaagi sa pag-ihap sa variable. Chapter 11, Singular Unquantified Statement. To understand how to analyze statement in predicate logic, we begin by distinguishing the subject of the statement from the predicate logic. The subject is the part of the sentence that specifies what the statement is all about. The predicate is the part that specifies what we are saying about the subject. In the following examples, the subject is the bold face. So, ang subject kuno is the bold. And the rest of the sentence is the predicate. So, I'm giving you an example. London is a city. So, ang London kay gibold face man, so mo ni ang subject. And the rest of the sentence is a predicate. So, ang predicate is a city. Another example. Jane got married last Saturday. So, ang Jane is a bold. So, the rest of the sentence is predicate. So, ang predicate na ni is got married last Saturday. And now we're talking what is categorical statement. In logic, a categorical proposition or categorical statement is a proposition that asserts or denies that all or some of the members of one category are included in another. The study of arguments using categorical statement forms an important branch of deductive reasoning that began with the ancient Greeks. So, ang usa kuno ka kategorya nga proposition o kategorya nga pahayag, usa ka proposition nga nagpahayag ug naglimod nga ang tanan o pipila ka mga miyembro sa usa ka kategorya, ang termino sa hisgutan gilakip sa lain ang termino nga predicate. Strategies for proof. We are now have all the rules we need for proofs in predicate logic. So let us consider some strategies that will help us use the rules in constructing proofs. As with proofs in propositional logic, we work forward from the premises and backward from the conclusion, looking for a route that will get us from the one of the other. We'll almost always need to use the propositional rules of equivalence and inference. So the strategies we learn for propositional logic are still applicable, but the rules of predicate logic require some additional strategies. Which rules we apply and how we apply them depend on the type of statement we're giving as premises and conclusion. We summarize these types at the end of section for our purpose in constructing proofs. We can simplify by reducing the classification to three kinds. And now we are talking about the proof. In predicate logic, as in the propositional logic, we use proofs to establish that a conclusion follows validly from a set of premises. We proceed step by step from the premises in accordance with equivalence rules and rules of inference until we reach the conclusions, the rules we learn in propositional logic along with the techniques of conditional and deduction proof are used for proofs in predicate logic as well. To work with quantifiers, we will also need to learn one additional equivalence rule for 4 additional inference rules. Proof with the relational statement. For arguments, the relational statement, we use the same rules and strategies for proof that we learned in the previous section. Suppose, for example, that someone made the following inference about the 2011 National Basketball Association playoffs. Example, if the Miami Heat beats the Boston Celtics in the Eastern Conference Finals, then if the Dallas Mavericks beat the Oklahoma City Thunder in the Western Conference Finals, Miami will play Dallas in NBA Finals. Dallas will beat Oklahoma in the Western Conference. So if Miami beats Boston in the East, it will play Dallas for the NBA championship. The whole summary of my report is predicate are used alongside quantifiers to express the extent to which a predicate is true over a range of elements, while a predicate with variables or predicate logic can make a proposition by either authorizing a value to the variable or by quantifying the variable. It is classified into quantified and simplified, which by definition is about classes of things, is about a specific person, place, time, or object respectively. In predicate, there is also proof that propositions which are equal or logical equivalent if they always have the same truth value. There is also the negation rules, which when we negate a quantified statement, we negate all the quantifiers first, from left to right, keeping the same order. Then we negative the statement. In addition to that, we have also tackled the relations and multiple quantification as well as the quantified relationship which is characterized by the interrelated phenomena. Intimate tracking. The collection of data arising from intimate behaviors and critical analysis or sexual and reproductive self-tracking using apps. In the final part, we have tackled the logical relations, which are a proof method employed in programming language semantics to show that two denotational semantics are equivalent and the overlapping quantifiers occur when one quantifier is within the scope of another quantifier. And the proof with relational statement, wherein for arguments with rational statement, we use the same rules and strategies for proof that we learned in the previous section. And that's all my report. Thank you and God bless.